Hello, today we'll be creating a Pong game with the hyperPad app, and we're just going to get right into it. So let's start by creating a new project. You can name this whatever you'd like. We'll click Next. We're going to leave the default orientation device support, but we're going to switch to bird's eye view. And now let's create our project. As you can see, when we load our new project, we start with an empty scene. We'll make this our main menu scene, so we can go to Scenes and rename it to Main Menu. To make this styled more like the classic Pong game, we can change the background color to black. And we can also add a label from the special objects to be a title. You can change this to the name of your game. And let's also change the text color to white. Let's change this font size to 72 and make sure the alignment is centered. We can click on this grid here so that when we're changing the position of our label, it snaps to the grid. Great. We'll come back to the main menu, but for now we're going to get started on the gameplay. Alright, so let's create our gameplay scene. We'll create a new scene. We'll name this game. And just like the main menu, we can change the background color to black and then create our scene. So this is the scene where all our gameplay is going to take place. Let's first start by creating our paddle. We'll go to Special Objects, create an empty object, and then we'll select the empty object that was just created. Let's change this color to white and turn the opacity up. And we can also name this to Player 1. We can change this to a physics object, but we're going to leave passable enabled. And in the Transform tab, we can set the X scale to 25%. Okay, now that we're happy with how our paddle looks, we can add some behaviors so that the player can control the paddle. Let's go to the Behaviors view. And we first want to start with adding a joystick with which the player can control the paddle. We'll go and drag this joystick analog behavior in. And we'll also go to Custom and add a box container, which will represent our move direction. In fact, let's rename this to Move Direction. We'll set the default value to 0, since when the game starts, we want the paddle to be non-moving. And we're also going to click on this Change Input Field button, so we have a way to change our move direction. We can drag this over to the joystick, connect them, and drag the output from the joystick on. We're using the Y output, which is the vertical up and down. So now when the player moves the joystick up and down, the paddle can also move. However, we also want the paddle to stop moving when the player is no longer touching the joystick. So let's go to Interaction. We'll add a Stopped Touching. Make sure this is selected on the joystick, which is in the Global UI view. So we'll select that. We're going to create another input field from the move direction. Connect the two, and we'll change the new value to 0. So now we have a move direction that changes when the joystick is moved and becomes 0 when the player stops touching the joystick. Now that we have a move direction value, we want to actually set the velocity of the paddle. So we can go to Custom Timer, and we can set this to 0, which means it'll refresh as often as it can. We also want to be able to clamp our move direction in a range. So we can go to logic and we'll add a minimum and a maximum. Let's connect all these in series. We'll set the minimum to take input from the move direction, and we'll put this as +1, so it's never bigger than 1. And then for maximum, we'll take the output from minimum. We'll put this as -1. So now we have that our paddle velocity is never smaller than -1 or bigger than +1. Let's go to physics, put a set velocity here, and we'll use the y velocity as the maximum value. Now we can test our game. As you can see, a joystick is here. When it moves, the paddle moves, and when it stops moving, the paddle stops moving. However, as you can see, our paddle moves very slowly. So what we're going to do is we can go back and add a multiplier to our move direction. We can disconnect the velocity, go to logic, we'll multiply values, and you can play around with this number, but for now I'm going to multiply by 20. And now we have a new value for our set velocity. So now if we test our game again, our paddle moves a lot faster. However, as you can see, a new problem arises because our paddle is able to move off the screen. So now we want to be able to add some boundaries to make sure our paddle can't move off the screen. So let's go back to the scene. And we're going to add another empty object. Let's make sure we're in the main layer. We'll go to special objects and we'll create an empty object. Let's click on that object that was just created. And we'll set the color to a dark gray and turn the opacity all the way up. We can go and keep this as a wall object, but disable passable. We'll set friction to 0% and bounce to 100%. Then in the transform tab, we can set the Y scale to 200%. And then this will be easier with the grid on. We can stretch this so it fits the width of the entire scene. We can also move this paddle over to the left, which is where it should be. Although we should make sure it's not too much to the left so that it doesn't intersect with this joystick. Okay, back to the wall. Let's duplicate this and use that for our bottom wall as well. And then we can duplicate it again and use this for our right wall. Let's set the right wall X scale to 200%. And then we can stretch that out. And then we can duplicate our right wall. However, as you can see, when we test our game now, the paddle still can go through the walls. So we need to add some behaviors to detect collisions and then move the paddle back within the boundaries. So let's go back to the paddle and add some more behaviors. Let's add first a check bounding box. And we can add an add values. Add values will take the bounding boxes, Y position and add it to the height. Now we want to be able to get the position of both our bottom wall and our top wall. So let's go to transform. We'll do a get position. We can connect these two. And then let's also rename these for readability. And we'll select the bottom wall. Let's do the same thing for top. Alright, cool. Now we want to be able to calculate the difference between the paddle's position and the position of the wall. So to do that, we're going to add a subtract. For the bottom wall, we'll be subtracting the position of the bottom wall, which is the Y position, the up and down position, from the position of the bounding box. And then for the top wall, we'll be subtracting the position of the top wall from that added value from earlier. That just incorporates the height of the paddle. So now we have the difference between positions. We want to check to see if the paddle and the walls overlap. So we can put two if statements, one under each of these walls. For the bottom wall, we want to check if our subtract value is greater than 0. And for the top wall, we want to check if our subtract value is less than 0. And when our wall and our paddle collide, we want to set the velocity of the paddle to 0, so it stops moving. That's the wrong one. Okay, let's do a set velocity. And we'll be setting this to 0. And now that our paddle has stopped moving, we want to set the position of the paddle so it's back within the boundaries. We've already calculated up here how much we need to move the paddle by, which is nice. So we can just go to transform. We'll do a move by, and we'll just use those values that we calculated earlier. This is the Y move by, which is up and down, and we'll just set that duration to 0. So now, when our paddle goes beyond the boundaries, we set the velocity to 0 and move it back within the boundaries. We can actually put a behavior bundle on top of all of this, just so we have a way of labeling this execution of behaviors. We can call this, let's name this something, check bounds. And we want to check the bounds every time the paddle moves. So we can go back to what we did earlier. We can put an execute behavior here, and we can execute the check bounds behavior. Now let's go back. Let's just anchor our top wall. We have to unlock this. Let's anchor our top wall to the top of the view and our bottom wall to the bottom. So when we test our game now, our paddle can't move beyond the boundaries we've set. Now that our paddle is moving, we can start adding a ball to our game. So let's go back and we'll click Special Objects. We'll create an empty object. And this empty object that was just created, let's set the color to white and turn the opacity up. We can rename this to ball for readability. We want to make this a physics object and disable passable. Just like the walls, we'll be setting the friction to 0 and the bounce to 100%. This is kind of big for a ball, so under transform we can set the X scale and Y scale to 25%. And we can also set the position to 50% for X and Y, so that when the game starts, the ball starts in the center of the game. Now that we like how our ball looks, we can start adding some behaviors. The first thing we want to do is have the ball stop waiting. The first thing we want to do is wait 3 seconds at the start of the game before getting the ball to start moving. So we can go to custom and add a wait behavior. And we can wait 3 seconds. And at 3 seconds, we're going to start moving the ball to the left towards player 1 in a random vertical direction. So let's add a random number. And we'll make this random number between -1 and 1. And then we can apply a force to the ball from the Physics tab. The X force is -1 since we're going towards the first player on the left. And the Y force will just be that random number we calculated earlier. The multiplier of 1 is kind of small, so we can change this to like 150. Now, when we start our game, we have our ball in the middle of the game, and after 3 seconds, it starts moving. As you can see, it rotates. So let's actually put a rotation lock on so that we don't have that rotation happening. That's just in the transform lock rotation. Okay, cool. However, as you just saw, it goes through the paddle, which we don't want. We want it to bounce off the paddle. So now we have to be able to detect collisions between the ball and the paddle. So let's go back to the paddle. We can go to the tag tab. Let's create a new tag. We'll call this paddle. So now the paddle is a paddle tag. We can go back to the ball, and in behaviors, let's detect a collision. And this will be between the ball and any object with this paddle tag. So when we collide with the paddle, we want to change the velocity of the ball. So first, let's do a get velocity. And then we're going to multiply our current velocity So our current velocity, which is the X velocity left and right, by -1.03. So what this does is negative switches the direction, and then 1.03 adds a 3% speed increase. Now that we have our new velocity value, let's actually set the velocity. This is our X velocity, and the Y velocity doesn't change. So now our ball should be able to bounce off the paddle. To make things a little more interesting, we can add another layer of complexity, which would be pitch. So what that basically means is that when the ball hits the top of the paddle, it pitches up, and then when it hits the bottom of the paddle, it pitches down. So now the player has a little more control of where the ball will go. So to do that, let's first be able to get the position of the ball and the paddle. So we'll do two get positions here. The first is the ball. The second is the paddle, which we can actually do by dragging the output from collided here and using object B. Object B basically means the object that is colliding with the ball, which is the paddle. And once we have these positions, we can add a subtract. So we can get the difference in these y values. So let's do the y of the ball and the y of the paddle. And now we can apply a force. And this force will just be in the y direction. And we can add a multiplier of, let's do 50. So now, when you hit the paddle, the ball with your paddle, where on your paddle the ball hits will also affect its position. Let's also add a clamp to the ball's velocity, because as you can see, every time this ball starts to move, as the game progresses, it starts to get faster. So let's just add a clamp. So after everything, let's do another get velocity. And then just like earlier, you can add a min and a max. So we'll do minimum, we'll use X, and then we can say 25, and then for the maximum, we can do negative 25, and that's only the X velocity, so let's do the same thing for Y velocity. So we'll add a min and a max again. So in this case, we're doing Y, let's do 10 for Y, which is up, down. And then for max, it'd be negative 10. And then now that we've clamped our velocity, we can set its new value. So we have our X, and we have our Y. So this just prevents the ball from getting like too out of control.